Hi guys. Here we are, just Captain American, clearly Iron Man.
Mm-hmm. Legit.
Okay. Yeah, we're here to talk about some mass-to-mass stoichiometry. So we've been doing that mole-to-mole stuff, and we figured we would fly you, if you will, fly, because we both can fly, right?
You can't fly now.
I can't fly anymore?
All you have is a shield.
Oh, I thought I could fly. Okay, never mind.
I think that's the worst swing in a
Okay, sorry. Well, anyway, so we're gonna just get you to go from mole to mass to mass, then I guess. Oh man. Okay, so we started with mole to mole, and that's going from moles of an unknown to moles of a known. Okay. And the two things you got to have is a balanced equation.
Cool. That's the big one.
Yep. And a mole ratio, which comes from the
Balanced equation.
Perfect. Okay. So today we're going to take it a step further. All right. And don't forget that your mole ratio is always going to be your moles of unknown on the top over the moles of your known.
Yes.
Okay. Or given in this either way. Same thing. Okay. All right. So here's our problem. We have C3H8 plus 3O2 yields 3 carbon dioxides and 4 hydrogens.
Nice.
Okay, nice balanced, easy equation.
Love it.
Okay, now here's our question. How many moles of hydrogen are needed to prepare 13 moles of carbon dioxide? This is what we did last time.
Okay, so this looks familiar, right?
Yes, this is what you should have already done. You know, you circle the moles of hydrogen. You know, you've done this, 13 moles. Okay, this whole part,
What
you
want,
line it up,
what you
right?
have, yeah,
Okay, so this should be
Perfect.
familiar. Okay, so here's our simple problem of C3H8 plus 3O2 yields 3 carbon dioxides and 4 hydrogens. Okay, now this problem is very familiar. It was on the last video, and
Nice
we
and
know,
easy. You got this.
we're gonna circle what we're looking for and underline
what
where we
you
start.
want,
Okay,
yeah.
so we
T-chart.
T-chart set it all up perfectly. That was really cool move you did there.
I'm pretty
Okay,
cool person,
yeah. Okay, and then of course the 4
Yeah.
moles of hydrogen over 3 moles of carbon dioxide is our mole ratio.
So 13 moles of carbon dioxide produces 17.3 moles of hydrogen.
Absolutely. Okay, so that's our ratio we came up from the balanced equation. Now we're going to take this a step further, and basically what we're going to do is we're going to put 2 more T-charts on both sides of that mole ratio.
Little sandwich.
Yeah, pretty much. Okay, so what we have here is a mass-to-mass
Love it.
stoichiometry problem. Okay, so we're going to take a new equation. We have nitrogen plus hydrogen yields ammonia, which is what kind of process?
The Haber process.
Okay, you know,
Fritz Haber.
fella,
Yeah.
high five. He gets a good.
Yeah, I mean, yeah.
He's awesome, really.
Well, I mean, killed a lot of people, but yeah.
Okay, but anyway.
Yeah, chemistry-wise, yeah.
Yeah. Okay, so what mass of NH3 can be made from 213 grams of H2? Okay, so down there at the bottom is kind of what I did is just kind of set it up. You're going to start with your mass of your known, so what they're giving you, so that'd be 213. Okay?
Yep.
Then you're going to need a conversion factor using molar mass to go from grams to moles, which
Okay.
we've done.
Yep.
Okay, that'll give you your moles of your known. Then you can use your mole ratio. You can use your mole ratio only once you're finally in moles.
Because it's moles and moles.
Exactly.
So you have to be moles.
So then you'll get your moles of unknown from that, and then you'll use the molar mass of what you're trying to find, your unknown, and that should produce your unknown mass, or your unknown amount for you.
Okay, so steps are I'm going to convert into moles, do some molar ratio,
Yeah, and then convert back into
out
grams.
into grams. Okay.
Yeah. Okay, so let's give it a whirl. Okay, so here's our equation. We underline what we know, of course, and
Yep.
we circle what we're trying to find.
Yep.
Okay, so we're going to write down what we know first, 213 grams of hydrogen.
Makes
Okay?
sense. Perfect.
Then we're going to draw our T-chart.
Whew, it's a long one.
It's a long one, okay? So the first thing I need to do is get rid of my grams. So my grams have got to go on the bottom. Okay, that's
Yep.
the molar mass of hydrogen. Okay, that's for every 1 mole of H2.
So I'm turning grams of hydrogen into moles.
Yeah. Okay. My grams are canceling. I can put on my next T-chart. Okay, now I use my mole ratio.
Gotcha.
So I have 3 moles of hydrogen according to my balanced equation. And then I have 2 moles of NH3, which come from my balanced equation as well.
Perfect.
Okay, because
Gotcha.
I was in moles, so I can use my mole ratio.
So convert into moles, do my molar ratio, and now this next step I convert out back into grams, right?
Right, yes. So my moles of hydrogen are canceled. I have moles of NH3 left right now at this point. So I'm going to do my next T-chart. I'm going to go from moles to grams. So again, I'm going to have to use molar mass because that's the only way to go from moles to grams. 1 mole of NH3 equals 17.04 grams of NH3.
Gotcha.
Okay? Now, all I do is bust out my handy-dandy calculator.
Boom.
And I am simply going to multiply everything across the top first. So 213 times 1 times 2 times 17.04.
Okay.
Okay? And I'll get 7,259.04. That's a big number.
That is
okay?
a big number.
Then I'm going to divide it by everything that's multiplied on the bottom.
Gotcha.
Okay? So normally in the past it's just been one number. Now we have numbers we're going to have to multiply first.
Yeah.
So 2.02 times 3, which will give us 6.06.
Yes.
Then I simply take top, divided by the bottom, and shabam!
Wow, that's a lot.
Yes. So if I had 213 grams of H2, I could make 1,197.86 grams of NH3.
Shabam indeed.
Shabam indeed. All right, so let's try one more.
Okay.
Okay, notice I put the green circle, that part right there, the mole ratio. That's the only way that I'm allowed to go from one substance to another substance.
Gotcha. So that's like the key, and everything builds out from there.
Yes.
Okay.
Okay, you need to have that for every single problem you do. All right, so here we go. Another one. We got magnesium plus sodium fluoride yields magnesium fluoride and sodium.
Okay.
Okay?
Sure.
So if you start with 5.5 grams of NaF, how many grams of MgF2 will be produced? So let's underline what we're starting with and circle where we're going. So grams to grams, I know this is going to be a long one. So I'm going to write down what I know first, 5.5 grams, draw my extremely long line,
Love it.
and start the T. All right, so I'm starting with grams. What's my first move, Mr. Wood? Or I mean Iron Man.
Yeah, please. Thank
Sorry.
you. Thank you.
Okay. Your cover.
So I need to convert my grams into moles. So I'm going to have to use my molar mass.
Uh-huh.
And I'm going to put 1 mole of NaF on the top.
Perfect.
Love it.
That was good, okay? So then I can tee up my chart.
Yep.
Since I'm now in moles, I'm going to use what?
My molar ratio.
Which comes from?
My balanced equation.
Okay, so NaF goes on the bottom. There's 2 there, and then I'm going to MgF2, so I'm going to put 1 on the top.
There's only 1 in the balanced equation. Good. Okay.
Now I'm in moles of MgF2,
Yep.
but I'm trying to get to grams, so now I do my next conversion, which is?
Good. I'm going to convert into grams using my molar mass.
Absolutely. So 1 mole on the bottom,
The
and then
molar mass of MgF2 on the top.
perfect.
Cool.
Yeah.
Love
Okay,
it.
so now I'm going to, again, multiply everything across the top. There it is. Okay, 342.71, and then I'm going to divide by everything multiplied on the bottom.
Yep.
Okay, divide the top by the bottom, and I should get
Boom. Oh, yeah.
4.08 grams of MgF2.
Fantastic.
Okay, now just make sure that you are writing down every single step, and you'll be fine.
Alrighty.
Okay, see you in class.
Bye.
Bye. Oh, mole ratio.
Bye.
Bye.